In this video, I will be explaining an important or most frequently asked interview question for mechanical engineering students, which is why carnot cycle is not used in steam power plant or thermal power plants. Okay, why do we use Rankine cycle instead of carnot cycle? Or in other case, I can say that what are the disadvantages of carnot cycle in a steam power plant? Okay, I will be this is the typical carnot cycle TS diagram. This is the high temperature, lower temperature, and this is the actual setup. This is a compressor which is going to compress the fuel mixture into high pressure, and it is sent to the boiler where the heat is added at constant temperature. As you see, from 2 to 3, the temperature is remaining constant, which means after adding heat in the boiler, the mixture is getting converted into steam, and the steam is allowed to expand in the turbine, and the turbine blades gets rotated, and it is coupled with a generator, and electricity is generated, and the expanded steam is sent again to the condenser where heat is again added at constant temperature from 4 to 1. As you can see, these two temperatures T4 and T1 are equal, which is TL, and again it is sent to the compressor, and this is our basically Carnot cycle. And let us see the same setup in a Rankine cycle. This is a typical TS diagram of a Rankine cycle. A big difference between Carnot and Rankine is, in case of Carnot cycle we are using a compressor, but in case of Rankine cycle we are going to use a pump. So processes, everything is almost same. 1 to 2 is isentropic compression in the pump, and 2 to 3 is constant pressure heat addition in the boiler, and the same process, the steam is getting expanded in the turbine, and again in condenser heat is removed at constant pressure, and again it is sent back to the pump. So I will explain the drawbacks of Carnot cycle now. So in this Carnot cycle, if you see 2 to 3 process, which is heat is added in the boiler at constant temperature, it is quite practical. But if you see the work done by compressor in this case is, the compressor in this case is handling both liquid and vapor mixture. So as we all know that work done by compressor is given by the formula minus integration of integral VdP. So for vapor density is much lesser, so specific volume, which is the reciprocal of density, specific volume of vapor is going to be pretty high here in this case. So the work done by compressor is going to rise exponentially. So the net work done, which is equal to work done by turbine minus work done by compressor, it is going to decrease. Since the compressor work is going to increase, the net work done or the power output we are going to get is very low. But in this case, if you see, this pump is handling only liquid mixture. From this point you can see this pump here it is handling only liquid mixture, but in this case the compressor is handling both liquid and vapor mixture. So in this case the work done by pump is quite less done compared to this case. So in this case the net work done is going to be pretty high, or in other words I can say that I will get much better power output and more power output in Rankine cycle compared to the Carnot cycle. So another reason is that in this case if you see, the point 4 is lying in liquid plus vapor region again. So but in this case if you see, point 4 is not lying in liquid plus vapor mixture, it is on the vapor side. So in this case if you see, when the liquids are allowed to expand the turbine, it goes and liquid will erode the turbine blades. So this is a huge drawback. But in this case, in case of Rankine cycle, if you see, the point 4, which is in vapor region. So the 3 to 4 expansion is taking place in the vapor region. So in this case, the turbine blades do not have any moisture or liquid content. So the turbine blades do not get eroded. In other words, we can say in this case the dryness fraction of 4 x4 is pretty less, and in this case we can say the dryness fraction is close to 1. So these are the two major reasons why we prefer Rankine cycle instead of a Carnot cycle.